Okay. Hi, everybody. We are starting Module 2 today for Eureka Math. And so this is Lesson 1. And the objective is to multiply multi-digit whole numbers and multiples of 10 using place value patterns and the distributive and associative properties. So very important that you understand what these properties are. Property is just a fancy way of saying you can count on it. You can count on it happening. It's going to work for you. It's predictable. So the associative property, starting with this one, it means you can change the grouping of the addends and get the same sum. And you can do that with addition and multiplication, and you guys are going to have all these notes already by the time we get to the work. And then with the distributive property, you can split it up or like distribute it, like you're passing out cards, you know, a little bit for you, a little bit for you, a little bit for you. And so you can take a number apart by place value positions and then put it back together. Now let me remind you, if you ever get stuck, this is just multiplication, and you can always rely on the standard algorithm to help you get the answer if you know how to do that. So sometimes kids will say, why do we have to do it this way? It's so hard. And I'm just telling you, you don't have to. What you need to do is try to understand these concepts and then apply them if needed. Okay? So yeah, we're going to be talking about unit form still. We're going to be taking numbers apart and then putting them back together. So you'll have all these notes. You can pause the video if you need to. And so finally, we are going to talk about the commutative property as well. And that's just moving the factors and getting the same answer, moving them around. So there are all these reliable properties that we'll be using with our math for Module 2. All right, so in your book, this is the Learn book. Just check, make sure, the Learn book. And it's Module 2, Lesson 1. This one starts on page 1 because it's an old one, but you guys will have whatever your page is for Lesson 1, Module 2, right in the middle of your book. There you go. So fill in the blanks using your knowledge of place value units and basic facts. So here they go, and they take apart this 23 times 2. And they're saying, okay, well, if I have 23 ones and I'm multiplying by 2 tens, let's just look at this 23 times 2, because ones times tens will give me tens. So just work on the numbers, and that's 2 times 3 and 2 times 2. And so you end up with 46 tens, which is 46 times 10, or 460. Okay, so you're able to do this all already, and it's nothing new. We're just taking this and going a step further. Sorry, I got to turn off my phone. It's like super annoying me. Okay, and so the same thing here. We've got the same numbers. Look at that. But we have an extra 0. So if you think about the 23 tens times 2 tens, and again, we're looking at, look, we've got tens times tens this time, but we still have the same digits, the 23 times 2, you would end up with 46 what? Hundreds. So tens times tens are hundreds. I put it on Do Not Disturb. Now stop disturbing me. Okay. So when you get down here, 230 times 20, it's again the same thing, but we have one extra 10. So it's going to be 4,600 in standard form, 4,600. But that makes sense. 46 hundreds, 46 hundreds. So continuing with just looking at the digits, 41 times 4. Now here they give you the answer because they're saying, all right, this isn't the important part. It's the, do you understand the unit form? So if I have ones times ones, yay, I'm just going to get ones. That part's really easy. And again, if you don't know what you're doing, just set it up with the standard algorithm. That can really help you to figure out, if you get stuck, to work with, okay, or what this means. And so then you continue and go over here, and if I have tens times hundreds, then my unit form should be thousands. And then my standard form answer is going to be what they have given you, but the unit form. And if it's 164,000, then it's 164,000. Now for this one, they're going to break it apart. And so how many tens times how many hundreds? So if I take these right here, 331 tens, times how many hundreds? What do you think goes there? Yeah, it's the 3, because this is what they're describing here. So then they've already solved the 331 times 3 to give you 993, but you have to figure out what this would give you. And tens times hundreds equals thousands. And so it's not THS, it's just thousands, because we're just dealing with whole numbers. So when you have this times this, you get your 993 and your thousands, whole numbers. Okay, and finally, on to the last one. Now this one, we're going to talk about this in class before we get here. But if you have this 5 times 6, you're going to need to watch out for the product, which already has a 0, because a lot of this is going to come down to counting zeros and paying attention to those place value positions. So if I have 5 hundreds right here times, look at that, 6 hundreds, that right there, 5 times 6 is giving you the 30. But if I have hundreds times hundreds, you can set it up here to see what you would get. 1, 2, 3, 4 zeros. 1, 2, 3, 4. 1, 2, 3, 4. So what is that? That is 10,000s. DS, not TH. So, excuse me, if I end up with the 5 times 6, write your product. Don't put any commas. Then 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, because I need to account for this 10 and this 10 and this 10 and this 10. And my 30 is already part of this 5 times 6 product. So your comma goes here, and you would end up with your 300,000. Okay? Now, this is going to be kind of a long lesson, so I'm going to kind of jump ahead a little bit. Make sure you got all that. And I'm going to throw down this that is completed, and I'm just going to talk through it. Determine if these equations are true or false, and defend your answer using your knowledge of place value and the commutative, associative, or distributive properties. So take a look at what they're showing you. 6 tens. Well, if I have 6 tens, it's 6 times 10, or 60. But on this side, the equal sign is supposed to balance it out. 2 times 3 is 6, but tens times tens is 100. Well, 6 tens does not equal 6 hundreds. So therefore, this is false. If I have all this on this side of the equation, and then I have this on this side, we're trying to identify where to compare. So if I have 40 times 20, okay, plus 4 times 20, which is this one, I'm distributing it out, okay, times 10, right here, don't forget that, equals, so you can start figuring it out, and as you can see, this is right over here. So 40 times 20 is 800, plus this 4 times 20 is 80. 880 times 10 equals 8,800. And then you can solve it and say, well, that's not the same. You can also look for different ways to pull out the 10 or find the 10 or compare, like on the next one. if I have 86 ones times 90 hundreds, then I also have 86 ones over here times 900 tens. It's really not relevant to include those two because they're the same. So those are not going to impact your equation. If they're both on either side of the equal sign, you don't really need those. What we're really interested in is the 90 hundreds versus the 900 tens. So when you look at 90 hundreds and see that it's 9,000, and then you look at 900 tens and see that that's 9,000, that is true. So you want to simplify or make the equations easier by finding what's on each side of the equal sign, because the equal sign is a balance, and then eliminate anything that's the same so that you can see what's different. And so right here, 64 times 100 would be 6,400, and then 640 times 10 is also 6,400. Okay, so that one is true as well. Now in the back, there's one more at the top, okay, before we get into what's on the bottom there. So if you take this one apart, again, kind of looking for what is the same, what's different, if you put the 57 times 10, then I have the same 570 that I have here. See? And then what you can do is you can identify that there's an extra 10 here, okay? Because this one is like 570, is like 57 times 10, if you break it out, times the 2 times 10, that's right here. But there's this extra 10. So because this side has an extra 10, it's not balanced, and this one is false. Now let's go to the other workbook so we can kind of work through these problems here. I'll do one, and then I'll pop up the answers. Okay, so it says find the product, show your thinking. The first row gives some ideas for showing your thinking. And here it's all kind of done for you, and they're just adding a zero here and here, adding this and this and this. So they're changing it just a little bit, but the basic fact remains the same. So you're going to use the first column fact to help you identify how to distribute or separate out each of these parts. Okay? So for the next one, 45 times 3, you can simply solve these by, it's essentially mental math, but you can also put your carried over number, like 5 times 3 is 15, so I would carry this over the next place value position. Then 3 times 4 is 12, plus 1 is 13. So you end up with 135. Then I'm going to take that fact right there, and I can kind of use it over and over. I can also separate it and distribute it if I want by taking, let's take, say, 40 times, sorry, 4, too fast, 4 times 10, okay, plus 5 times 1, I could do that, oops, getting into my next space, times 3 times 10 if I wanted to do that, and then you can have, or I could just do 45 times 30. 45 times 3 is your 135 times 10. Okay, so you can break it apart if you're not sure how to multiply or you want to take it apart because it's easier. Okay, but anyway, you get back to this 135, the first fact, times 10. And this is going to give you that extra place value position for here, okay? So if I have 45 times 3 times the 10 from here and the 10 from here, then I still get that basic fact, and then I'm multiplying by 100. Then I have my basic fact, and I have 2 more positions. So my answer, as it would make sense, is the same basic fact, the 135. Here I have 1 0, and here I have 2 zeros. So it's not complicated. Once you get the hang of it, you're going to see all these patterns. Again, the same basic fact. If you want to do it this way, here's a 10, and here's a 100. Same basic fact. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay? 135. 1, 2, 3. Easy peasy, right? You guys are going to ace this page. Okay? So, to save time, I'm going to show you that this is essentially what you're doing. You're taking your basic fact, although I am going to stop here for one quick second. The 4 times 5 has 20. That's your caution. Caution. Use your basic fact with this 0, and in the notes we're going to have zeros in different colors when, or in the introduction, we're going to do zeros in different colors when they're part of that basic fact answer, so that you don't forget it's not 3 zeros, it's 20 and then 1, 2 zeros. Okay? 4 times 5, there's your 20, but 1, 2, 3 extra zeros. 4 times 5, there's your 20, and 1, 2, 3, 4, 5 extra zeros. Basic fact, 1, 2, 3, 4, 5 extra zeros. Okay, so be sure and think actively about it as you're completing this page. This one has like a bigger basic fact, so this is where you can kind of separate it out. Here we're taking the 7 from the hundreds place and multiplying it by 2 because that's easy. And then take your 18 and multiply it by 2 because that's easy. So you put it all together and you have your 1436. And then you use that basic fact to carry you through as you only do the 718 times 2. Then take your 10 times 10, 10 times 100, okay, or, oh yeah, I had kind of gone both ways on this one. Here's your 10 times 100 and your basic fact, and then 718 times the 2 right here, but I set it up first with the 100. So all of this is supposed to help you with breaking it apart and redistributing it so that it makes it easier for you, okay? And especially with all these zeros, okay? Now, for the last page, we have just a few word problems. And so actually, I think what I'll do, keep this up because it's almost 20 minutes. Don't want to go over 20 minutes. So Riley told his mom that multiplying whole numbers by multiples of 10 was easy because you just count zeros, oh dear, in the factors and put them in the product. He used these 2 examples to explain his strategy. And Ripley's mom said his strategy will not always work. Why not give an example? So, you know, if you have a 7 times 6 is 42, that's okay. There's no 0 in the product. 8 times 7 is 56, like Ripley is saying up at the top. 56 has 2 digits and neither is a 0. However, if you use 5 times 6 or any other time when you multiply with a number and you get a 0, you would miscount the zeros because you may not include this one. That's the big idea. On number 5, the Canadian side of Niagara Falls has a flow rate of 600,000 gallons per second. How many gallons of water flow over the falls in 1 minute? Like I always say, convert so that you're using the same unit. So we want seconds, and we need 60 of them. And then this is how much per second. So this is how much per the 60 seconds that are in a minute. Using the same strategy, take the 6's out and take the 100,000 from here, and the 10 from here, and you will solve that and get 36 million gallons per minute. And finally, for the tickets to a baseball game, you guys should be able to do this without me. $20 for an adult ticket, $15 for a student ticket, 45 adults get tickets, 600 students get tickets. Put it together. You can take this apart and do the 2 times 45, and then don't forget the 10, and do the 600 times 15, and it's essentially 6 times 15, and then there's the 100. Get 90 times 10 or 90 times 100, put them together, and you spend $9,900 on tickets, just like that. That is lesson 2, kids, and so we'll be covering that real soon. See you soon. Bye.